now ready to start the wonderful world of trigonometry as we begin Chapter 4, Section 1 on angles and their measures. Now, in geometry, we studied angles. We talked about how angles were two rays that had a common endpoint. We're going to define it a little bit differently here. We're going to define an angle by a ray that's formed. The angle is formed by taking the ray and rotating it about its endpoint. Now I've got it rotating this way with my little dotted arrow there to show that it's going to have the original or initial side and rotates to the final or terminal side, and you have this angle that's right here that's formed. The vertex, of course, is this common endpoint here. Now, we talk about angles and we talk about their measures being in degrees, but as you'll find out in this section, they can also be measured in a unit called radians. So it's really important that you try real hard to kind of understand the idea of measuring an angle in ways other than we're traditionally used to with measuring things in degrees. Now, an angle is considered in standard position if its vertex is at the origin of the xy plane and its initial side is on the positive x-axis. So if I was to have a set of axes drawn here, kind of freehanding it, and I was to put, let's say, an angle in standard position, the initial ray or initial side would have to be in the positive direction of the x-axis. Now what we consider the angle, remember how I rotated it this way in a counterclockwise manner? If I did that here in a counterclockwise manner, we consider that angle to have positive measure, and we call it theta. They love using Greek letters to represent the angles, and you'll see theta quite a bit here. So if it's rotated counterclockwise, we are looking at this as having a positive angle measure. Now this is only when we're talking about standard position here. Okay, that's the key term. And if it's rotated clockwise, then we consider it to have negative angle measure. So if I had something along the lines like this was my initial side here, and I rotated it this way, then this angle, which we could call, let's say, alpha, which looks a little bit like a fish there or something, we would say that that angle in green has negative measure. Now, of course, you're already aware of the fact that when you do a complete rotation or revolution, so if I have it in standard position here, and I go all the way around like that, that one revolution or one rotation is in degrees, 360 degrees. I had a buddy growing up that when he drove on icy roads, he knew just how to lock the brakes so that he could get the car to do a complete spin or a 360. So hopefully that's not how you think of 360s. You think of 360s in terms of angles here in geometry or in trigonometry. Now, the various types of angles that are special angles that have special names, of course, are your right angles, which are 90-degree angles, your acute angles, which are less than 90 degrees, positive angles between 0 and 90 degrees. Obtuse angles, those are angles between 90 degrees and 180. Straight angles, which are angles that look kind of like a line when you draw them out because they have a measure of 180 degrees. And of course, special pairs of angles, complementary angles, are two angles whose measures add up to 90 degrees, and supplementary angles are two angles whose measures add up to 180 degrees. Now this is all from your geometry days, your pre-calculus days, so hopefully these are terms that you're familiar with. Now, 360 degrees, we think of a degree as being the smallest possible unit of measure, but you can take a degree and you can break it into smaller units. In fact, 1 degree, if you were to, which is a pretty small angle, if you were to split this into 60 equal parts, we call each one of those parts a minute. And so 1 degree is equal to 60 minutes, or 60 with a tick mark like that. That looks a little bit like the mark that we use when we're talking about feet. But with respect to angle measure, you see the single tick mark, you know that it's referring to minutes. So if you can think of a really small angle of 1 degree, which I can't draw with a pen like this because it'll just smear the initial side into the terminal side, if you break that into 60 equal parts, each one is considered 1 minute. And then if you take one of the minutes and you split it into 60 equal parts, we get seconds, kind of like we do with time. So that 1 degree, which is 60 minutes, 1 minute is 60 seconds, and we use the double tick mark, which is kind of like for length, inches, to represent in seconds. So 1 degree, which is 60 minutes, and each minute is 60 seconds, means that 1 degree is 3,600 seconds. And 1 second, on the other hand, is 1 over 3,600 degrees. So you can imagine how exact we can measure an angle if we break the degrees down into minutes and into seconds. In fact, we don't typically write it out with the words. If we have 35 degrees, 21 minutes, 18 seconds, we write it like this. We don't put commas in between, but we do put a little bit of a space in between each part of the measure. So 35 degrees, 21 minutes, 18 seconds. Now, once we have kind of absorbed that, what we want to be able to do, we don't do it a lot, but we do it enough so that we want to practice it, is to be able to convert what's sometimes referred to as degrees, minutes, second form, that's what I have here, into what we sometimes refer to as decimal degrees. At least this textbook uses that term. Decimal degrees means we want to write this as 131 point, and then how many decimal places in terms of that decimal part of a degree. So what we're going to do is we're going to go to this definition. We're going to take 131 degrees. This is 12 minutes, so that would be 12 out of 60 minutes. So this would be also in degrees, because that's a fraction of a degree. And then we're going to add on to that 33 seconds, which would be 33 seconds out of 3,600 seconds, which is equal to 1 degree. So out of 3,600, and this is also in degrees. Now, I don't have my calculator on me right off the bat, but if I was to get my calculator out, divide 12 by 60. Now 12 divided by 60 actually isn't too bad. That's 0.2. So there was going to be a 0.2 here, but we'll also have to consider these, which I think is going to be a lot smaller than 1/10 of a degree. I just happened to work this problem out in advance, and this turns out to be 0.2092 degrees rounded to the 4th decimal place. So change the minutes into degrees by dividing it by 60, change the seconds into degrees dividing by 3,600. Now we can reverse this process. We can take what they refer to as decimal degrees and change into degree, minute, second form. So this is going to be 26 degrees plus, now, 0.48. Well, first we're going to find out how much 0.48 is in terms of minutes. So we're going to multiply 0.48 times 60 minutes, because that's how many minutes are in 1 degree. And if you do this, and I'm going to do a little scratch work here, 0.48 times 60, I didn't write this one down, so that's 0.8, carry a 4, that's 28 with 2 decimal places, and I get 26 degrees plus, and I'm going to put a plus sign for right now, or actually I'll just write it as 28.8 minutes. Well, I want it in degrees, minutes, seconds, and you can see I have a decimal point of a minute here, so now I'm going to change this to 26 degrees, 28 seconds, and I'm going to take this 0.8 and I'm going to add this on by multiplying 0.8 times, well, we know there's 60 seconds in a minute, and this is a decimal of a minute, so times 60. And this is going to be in seconds. So I'm going to have 26 degrees, 28 minutes. Now if I multiply 0.8 times 60, I get 48. This is going to be 48 seconds. So it's just a matter of doing a little bit of arithmetic to change one form, decimal degrees, into another form, degrees, minute, second, or vice versa, and here are 2 examples of that. Alright, with that stated, it is time to unveil the idea of measuring angles in radians, and that's going to be in the next video.